This video is for the Simplifying Radicals notes. There's 3 note pages here, but the first one's real short and sweet. The second one is already filled out for you. So first thing we're going to talk about are the parts of a radical. So this sign here is not the square root sign. This is a radical sign. And it means to find the square root of the number that's underneath it. Now, this number here is called the index, because we don't just have square roots. If we change the index, we change the meaning. So here it's a square root. What number times itself gives us 46? Okay. If this was a 3, that would be what we call a cube root. That would be what number times itself 3 times would give us 46. And then the number underneath the radical is called a radicand. Okay? So if there's no index, if they don't put a number here, it's understood to be a square root, to be a number 2. If they don't put this index number here, you just treat it like a regular square root. Square roots with negative radicands, so if this number underneath the square root is a negative, have no real solutions. Now that's with a square root. Cube roots are a different story, but just understand that if the number underneath a square root radical is negative, there's no real solutions. The second page of notes you have is this perfect squares and perfect cube page. This helps you when we start simplifying these radicals. This is a good reference to look back at. So our actual notes for the day are simplifying these radicals and how we do that. Sorry, guys. All right, so we need to simplify this radical. So the reason we need to simplify, if we type that in the calculator, let's see here. If we do the square root of 360, we get this long, crazy decimal. This is an irrational number. We want to keep things as nice and neat as we possibly can. Okay, so the first thing that we want to do if we see that we have got an irrational number is factor the radicand. So we want to factor 360. So there's different ways to do this. Start with a factor that you know. 360 is even, so I know I can divide it by 2. Okay, I can divide 180 by 2. I can divide 90 by 2. 45 is where I can no longer divide by 2. So I know that I've got right now 2 times 2 times 2 times whatever's left, 45. So again, I'll work backwards. Gives me 360. So now I need to break down this 45. So anything with a 5, my first go-to, I'm going to divide it by 5. So now I've got 5 times 9. 5 is prime. I'm looking for prime numbers. So now I need to break down that 9. 9 divided by 3 is 3, so 9 breaks down into 3 times 3. So if I factor 360, I can break it down into its prime digits, and I put them out of order. You normally put them in numerical order, so I'm sorry for that. But if I work backwards here, multiply them all back together, I missed a 2. I get back to 360. This is important. We need these factored. So I'm going to rewrite the factoring with exponents. So 2 times 2 times 2, I can rewrite that as 2 to the third. 3 times 3, I can rewrite that as 3 squared, and then times 5. All right, step 3. I'm going to write each of these factors underneath a radical. So I'm going to write the square root of 2 to the third times the square root of 3 squared times the square root of 5. And I'm going to break down anything that I can break down. So roots and exponents are opposite, so they cancel each other out. If any factors are raised to the power of the radical, and exponent, or power of 2, sorry, you can't see that number there, power of 2, the radical and exponent cancel each other out. Now, in this case, where we have one raised to the 3, what I can do to that one, the square root of 2 to the third, I can break this one back down. Okay, what I want to do is I want to make this one the square root of 2 squared times the square root of 2. Okay, so when you're working with a regular square root, you might want to group in just 2's. Okay, so we could break this 360 down. I could have done 360 equals 2 squared times 2 times 3 squared times 5, and then done the square root of everything. And the reason that I do that is because this square root, this radical, cancels out that 2 for me. Okay, so just like with the 3, this square root radical cancels out that 2. Okay, so what I'm left with, if these cancel, I'm left with here 2 times the square root of 2, and here I'm left with just a 3. So now I can kind of combine all my pieces back together. So I've got 2 to the square root of 2 times 3, and I still have that square root of 5. I can't square root 5. That would still give me an irrational number. What I can do is I can multiply my coefficients. Okay, so my coefficients here are this 2 and this 3. So if I multiply 2 times 3, I get 6. And then I'm still left with this square root of 2 and this square root of 5. Well, with radicals, as long as these are the same type of radicals, these are square roots, I can multiply the radicands. So I'm running out of room here. So I'm left with 6 times the square root of 10. Okay, so we're going to practice this several times. So let's start with 8. So if I break 8 down, 8 is the same as 2 times 2 times 2. Okay, so I'm getting those 3 2's from this 2 here, this 2 here, and this 2 here. Okay, so square root of 8 is the same as the square root of 2 squared times the square root of 2. So I'm just grouping 2 of these together so I can cancel out that radical. Okay, so this radical cancels this exponent, and I'm left with a 2. I still have this square root here, the square root of 2. And there's nothing to simplify there. All right, so 45. Let's start with 45. We know it's divisible by 5, and I'm left with a 9. So I've got 5. 9 is divisible by 3. So I'm left with a 3 and a 3. So 5 times 3 times 3 is 45. Always work backwards if you need to. So if I break this down, so I've got 2 of these, so I can do the square root of 3 squared, write it with an exponent so that I can cancel that exponent in the end, times square root the 5. So this radical will cancel this exponent, and then I just tack the other radical onto the end. All right, 162, even number, so I'm going to start off by dividing it by 2. So we know we're going to have a 2. 81's not even, but 81's divisible by 9. So I know I've got 2 times 9 times 9. Okay, 2 times 9 times 9 gives me 162. But 9's are not prime. 9's are really 3 times 3. So I'm going to break this down even further into 2 times 3 times 3. That's the first 9 times 3 times 3. So again, working backwards, I get my radicand. So I'm going to square root the 2. There's nothing to combine it with. And then I'm going to group these 2 at a time. So the square root of 3 squared times the square root of 3 squared. These are going to cancel. Okay, so what I'm left with here is the square root of 2 times 3 times 3. Now I want to flip this around. I want to do the 3 times 3, and I get a 9. Ooh. And then just tack that square root. You want the radical at the end. All right, 847 is kind of a tricky one. So we know it's not even, so let's start with 3. Not divisible by 3. Not divisible by 4. We know it's not divisible by 5. Not divisible by 6. Is divisible by 7. So we know we have a 7 there. So now we need to check 121. Okay? 121 And you can just work through the numbers. 7, nope, 8, 9, 10, 11. Now, here's where this other page comes in handy. So we know we have this 121 here. If you look at this other page, you can look for those numbers. So here's that 121, and the square root of 121 is 11. So we know that 11 times 11 gives me 121. Again, working backwards, 7 times 11 times 11 gives me 847. So I'm going to have the square root of 7 times the square root of 11 squared. So this is going to cancel. I want to write this 11 first because it's the prettiest. No frills on it. And then tack the square root of 7. Again, you can check your answers also. I can type in 11 times the square root of 7, and then I can type in the square root of 847 and see that I get the same thing, which means that I did simplify this correctly. All right, 27. So we know 27 is divisible by 9. That gives me a 3. And then we know 9 is divisible by 3. So that gives me a 3 times 3. 3 times 3 times 3 gives me 27. So again, I just want to group 2 of these. So square root of 3 squared times, don't forget your last 3, radical and exponent cancel, tack on the remaining radical. All right, 224. 224, let's divide it by 2, and let's see what happens. So we get 112, okay, and then 112 divided by 2 is 56, so I can divide that by 2. 28, I can divide by 2. 14, I can divide by 2. And then I'm left with a 7. Again, if I go back, I've got 5 2's. 1, 2, 3, 4, 5. Make sure that I factored it correctly. All right, groups of 2. So I have the square root of 2 squared times the square root of 2 squared times 1 lone 2, 1 lone 7. Okay, this cancels. This cancels, so I'm left with 2 times 2 times the square root of 2 times the square root of 7. So this is still messy. I can clean this up. So 2 times 2 is 4, and then I can multiply what's underneath these radicals. 2 times 7 is the square root of 14. Okay, again, real easy to go back and check your work. All right, cube roots. Same idea here. We're going to factor the radicand. So we've got negative 24. So I'm going to get rid of that negative sign right off the bat. Whoop. All right, I'm going to do negative 24 divided by negative 2. So I know that I have negative 2. Now it's times 12. So I can divide that by 2. I can divide the 6 by 2. And then I'm left with a 3. Okay. Negatives make these more difficult because there's many options here. Okay. I could have also done negative 24 divided by negative 2 divided by negative 2 divided by negative 2. And I'm still sitting at the same position I was. So what I want to do, because this is a cube root, I know that I can get rid of that negative sign, but I need 3 of them to be able to get rid of them. Okay, it's a cube root, it's to the third. So to get rid of this negative, and I'm not even really getting rid of it. Okay, I'm going to rewrite this. Negative 24 equals negative 2 to the third times 3. And then we're going to write these under a radical. but it's a cube root radical, so you need that little 3. Negative 2 cubed times the cube root of 3. So this cube root radical, this 3 radical, is going to cancel this 3. So again, I didn't really get rid of the negative, but I have to have the same number 3 times. And if I just did negative 2 times positive 2 times positive 2, that's not the same number. Negative 2 and positive 2 are not the same number. So you have to have 3 of the exact same number for it to cancel. So I'm left with a negative 2. Well, I canceled it up here. I should have canceled it down here. But I'm left with a negative 2, and I'm left with a cube root of 3. So how I combine all that, I just smush everything together. Okay? So remember, with negatives, a cube root will get rid of a negative. You just have to have 3 of those negative signs. All right, 500. We know 500. Let's do it. Let's divide it by 100. Oh, and it's a negative. So negative 500. Oops, sorry. Negative 500 divided by 100 gives me a negative 5. Okay. Now I know that I still have to get rid of this 100. So I know 100 is divisible by 5. So I'm going to divide it by another negative 5 times negative 5. And then I know negative 20 is divisible by a negative 5. And I'm going to show you another option for working these out. And then I'm left with a 4. So we know 4 is 2 times 2. All right. As long as I have 3 of the same number, I can cube root that negative 5 cubed times the cube root of 2 squared. So this cube root is not going to cancel that 2. Okay? This cube root will cancel that 3 though. So I'll be left with negative 5 and then a cube root, and I'm going to go ahead and work this out. 2 squared is 4. That is simplest form. This is not simplest form. The cube root of 4 is simplest form. Okay? So now we're back to positives. Positives are easy. No extra rules to remember. So I'm going to start with dividing this thing by 5. 35 is divisible by 5. And then I'm left with a 7. So group of 3 here. 5 cubed times the cube root of 7. So cube root cancels the exponent of 3. So I'm left with a 5 times the cube root of 7. All right, another method for these negatives. I'm going to treat it like a positive. Okay? Divide it by 2 here. Just remembering that I'm going to have 3 negatives somewhere in the end. So 56 is the same thing as 2 times 2 times 2 times 7. 2 times 2 times 2 times 7. So let's see what happens when I make that negative 2 times negative 2 times, try that again, negative 2 times the positive 7. I get negative 56. So that kind of helps me know where to add my negative sign in there. Okay? Cube root of negative 2 cubed times the cube root of 7. Cube root cancels the exponent of 3, so I'm left with a negative 2, and then I just tack on the cube root of 7. All right, 32. 32 divided by 2 is 16. Divide it by 2 again, and I get an 8. Divide it by 2 again, and I get a 4. Divide it by 2 again, and I'm left with a 2. Don't forget your last 2 here. If you count up here, 1, 2, 3, 4, 5 2s. Okay? Remember to group in threes. Okay, cube root of 2 cubed equals, now I've got 2 squared here. I'm going to go ahead and work it out because I know that an exponent of 2 is not going to cancel out for me. Okay, so cube root cancels the exponent of 3, cube root of 4. How do you do a cube root in the calculator? Cube root of 32. This one's really weird in the calculator. You're going to raise it to an exponent, and that exponent is going to be the fraction of the cube root. 32 to the third power is the same thing as the cube root of 32. Same thing as square roots, okay? Square root of 16 we know is 4. But I could do 16 to the power of 1/2, and it's the same thing. These two mathematical operations mean the same thing. One of those oddball things you need to be shown. All right, 189. 189, we know it's not divisible by 2, so we're going to start with a 3. All right, we're divisible by 3. Let's see if 63 is divisible by 3. It is. 21 is divisible by 3. And then 7's my other prime number. So I've got 3 3's, 3 cubed, times the cube root of 7. Cube root cancels the exponent of 3. Tack on what's left. Oh, but it should be negative. I'm so sorry. That should be a negative 3. So to prove it to you, negative 3 times negative 3 times, oh, I keep doing that. Negative 3 times 7 gives me negative 189. I apologize. All right, 216. No, it's divisible by 2. 108 is divisible by 2. 54 is divisible by 2. All right, now we got a 27. All right, well, we know that one's divisible by 3. And then we know that this 9 is the same as 3 times 3. Again, always you can go back and check. Make sure that everything multiplies outright. All right, so this one, we've got a group of 3 here and a group of 3 here. So we've got the cube root of 2 cubed times the cube root of 3 cubed. Cube root cancels exponent of 3. Cube root cancels the exponent of 3. So I'm left with 2 times 3. Again, simplest form gives me a 6. So sometimes they simplify out real pretty. So 216, again, I can raise it to the power of a third, gives me a 6. So to type something like this in your calculator, this is how you have to do it.